End of presentations, two presentations that will, we hope, inspire you. We're going to hear Sindre Bornstein from Nordic Innovation. I mentioned him earlier. He's going to talk to us about the Nordic Vision 2030, competitiveness and innovation. But before we get to that, I'm pleased now to introduce to you Hanne Shapiro. She's the lady in red, and she's also an experienced and qualified person in this context in many respects. She's worked for the Danish Institute of Technology for a number of years and is also one of the pens behind the document on recommendations from Anne that I think we've discussed earlier a few times. So on the title board, we have Europe's global competitiveness, and I think we're going to do it in such a way that Hanne gives the floor, gives her presentation, which is mainly presentational, but we will have opportunity for a question or two at the end, or even a comment. Hanne, very pleased to have you with us, and the floor is now yours.
Thank you very much, and I'm very, very happy to be here and honored to be here. Thanks a lot to Anne for amazing collaboration, and not least to you, Tove. It has really been a pleasure, and from my perspective, the work is only starting. I want to put out a sort of rhetoric question to kick off. If you think about Dresden semiconductors, if you think about Paris quantum computing, if you think about Finland batteries or Jutland wind technology, people will say, well, it's about investment in labs, it's about investment in R&D infrastructure. But at the end of the day, when people go home, or God forbid it, people leave at scale, then these environments are worth very little very quickly, because it's people that make the difference. And people, when we talk STEM talent, highly mobile, highly sought after, and yet we know extremely little because we don't have the data about mobility patterns. What at the end of the day makes Europeans leave their home country? Mobility within Europe or people coming to Europe? And that'll be sort of setting the stage for today also, where one of my main arguments are, yes, we can talk about STEM as an education policy, but key message, and which we have been discussing in Anne, is really we have to frame it as an industry policy. And why is that? If we look now, we had a lot of different policy measures more recently around AI. We have the whole zero agenda. We have the CHIP Act and so forth and so forth. And all of these are all very, very good, but they're just strategies and paper. And it strikes me, with none of these strategies have we seen the implication of what will it require in terms of human capital, when, at which stage, just roughly the composition of them, not part of it. So when we say that STEM should be part of the European semester, it's also really to push that agenda. When new major technology proposals come up, we have to think in all acts about the human dimension. How do we solve this problem? And when we look to, and I won't do too much about the diagnosis, because you can read about that in the report, and it follows. We were very happy to see that it follows a lot. Actually, we were earlier than Dagi were, but we did our job well. But to talk a little bit about the diagnosis, still, I just saw that China just here the other day, in fact, have implemented now a tech visa. So you no longer need to have company support, so you can move very quickly into China. They're doing enormous amount now to attract Chinese researchers back from the US and building these giant labs. And in China, they're not just working on large language models. No, one of the major AI researchers is in fact looking into small language models and what that means also to the whole AI development. So they are building on very different types of scenarios. And even if Trump now is closing down, or he's not closing down completely, but cutting in National Science Foundation funds and threatening universities, trying to steer what curriculum they have, still have an enormous attractiveness. And these both of these countries, both China and US, what they have done is really building platform-based companies that have scaled enormously, and they have huge resource concentrations, and they are magnets for talent. As we already talked about earlier today, we have great startup environments, but they don't scale, and we don't use the European inner market. I won't talk more about the siloed thing because we talked about it this morning, so let's move on a little bit. The STEM acronym. I'd like to get into that because I've actually worked with STEM and also wrote a report that was highly debated at the time. Does Europe need more STEM graduates? Published by the European Commission. And it has served us well, this acronym, because it has brought STEM on the policy agenda. But it's absolutely hopeless in terms of making policy. Because, first of all, demands differ hugely across fields. We are not equally short of mathematicians, physicists, and software engineers and battery technicians. It looks different. We are also seeing that STEM skills become important in other fields that didn't used to be considered STEM, be it health, be it financial services, which is becoming more and more STEM intensive. Plus the fact that even within Europe, we define what STEM statistically, we define it differently. So we have very, very big difficulties actually to understand what is the stock of STEM skills, where are the gaps and so forth. Plus, we also see these different forms of convergence driven, not least by AI and ICT. And we know anyway from work that I recently completed that within AI, the speed of skills obsolescence in AI-intensive occupations is so much faster than traditionally. So blurring boundaries between profiles, hybrid profiles, rapid skills obsolescence, we need a more granular understanding of what is happening within this whole field. Let me give you an example. For example, in the medical field, in cancer, my husband has recently been through a cancer treatment. And I think he met more physicists and mathematicians than he met doctors. And they made a huge difference because they can do all the calculation for absolutely precise treatment. So what do we do with this? Did I jump over one? STEM intelligence. Yeah, I want to talk a little bit about this. Because if we look at what Europe has done till now, we have built ESCO. And I don't know if, do you know what ESCO is? Well, it's a language. It's a way of systematizing language between the language of qualifications and the language of occupations and labor market. And that's a brilliant idea, except for when you begin to work on it in fast-changing occupations, like all the different STEM fields are, it's far, far, far too big in its constructs to really be meaningful. Plus, it's not updated. So if you work in any of like data science, quantum computing, whatever it may be, you don't have a language. So that's one set of issues. There are many different CEDEFOP, the Agency for Vocational Education and Training, do a really brilliant job of monitoring the labor market with skills forecast, something called OVID, which looks deeper down in occupations. And there are many, many different, plus there are different type of surveys going on also from European Foundation, but it's very fragmented. It's impossible for, I was about to say any normal person, but I don't mean that, but as a working tool for, be it for the engineering associations or for education providers, there are so many different sources you have to combine. And what we are also seeing now with both European University Alliances and with European Institute of Technology, each and every alliance, if they do skills anticipation, each and every one have their particular methodology and their particular way of going of things. It's very good for consultancy companies, but it does not give any comparability. It does not give any granularity. So that's a challenge. And we do have examples of where it actually works. One place to obviously point to is Singapore, where they have built their futures economy strategy with transformation maps. Where is it we want to position ourselves in global value chains? Where is it we want to attract talent? Where is it an inward investment? Based on that, then on a sectoral basis or value chain sectoral basis, they simply make visions. Where is it? If we look 2 to 3 years ahead, looking into pattern data, looking into the most advanced companies and their demand, where is it they are heading? They do not give a precise indication because, of course, you cannot say this is exactly what it will be like. But it gives a very good navigating instruments for education and training providers. So on top of that, they have the education and training providers with the skills futures, funding, common funding structure with learning accounts, and a platform where you can go in and navigate and say, I'm here in life, I would like to move over there. And you see the skills and occupational pathway you can follow. Belgium does something to that extent also, so it can be done. At present, we have an infrastructure project going on with the Finnish head AI is a part, and which is interesting because that's one of the initiatives to create a common data space for skills. But my worry is it'll be yet another project that at best will be a pilot with some specifications, and then it'll end because the funding ends. So I think that is where we maybe could think also push the Commission to continue this, make some business cases around critical technologies, possibly pick some clusters and get it out and begin to pilot what it could look like. But that's just one example. No, I'm going the wrong way. Sorry, I just ripped now I need help. I ripped my ligament here the other day, so I'm not in a super good position with my shoulder. Here we are. Yeah, if you just put in my apologies because I can't really control my fingers so well. Yeah, here. No, yeah, here we go. Yes, good. STEM is not just STEM, as I said before, also from another perspective. I tried to just do some rough mapping with some of the data I have available. And you see the y-axis is the relative growth in demand for skills from 2019 to 2024. And the other axis is how many sectors are asking for these particular skills areas. And as you see, the bigger the circle, the more and the higher up, the more demand, the more companies demand it, and the more sectors demand it. So you can see that the AI skills area, which is both machine learning and generative AI, because I tried to group them, goes across 14 sectors and more than 90,000 companies that are demanding this set of skills. Another area that has really seen a high growth is in cybersecurity, that has just in very, very short time exploded in demand. And obviously, again, also with all the cybersecurity threats, et cetera, that we have. We also see with the other diagram, we see that these skills really pay out, particularly when you have some years of experience. They just give a very deep salary increase. And the little gray dots down there, that's all the other skills areas, so much more modest demand. If you now can imagine that you grew this up, not just in these big numbers like here, but a little bit more granular, how you could use that as a provider, as a trade union, to go in and say, hey, this is what we can see now from our data, because this comes from labor market data. This comes from mining company job ads in Europe. It comes from also the statistics from CITFOP and so forth. Then we have much more refined instruments than we have today. And we can also begin to see, or I began to look a little bit at the outliers that are beginning to emerge and have more space. Yes, quantum computing. quantum computing is really growing now, but only starting here in 2024, where you can really begin to see it. Another area that's really beginning to take more space is human AI interfacing. And it doesn't surprise me, having recently worked a lot in finance, because I can see how they begin to ask more for people with a combination of data science skills, but also being versed out in AI ethics, data governance, and so forth. So you can, if you spend some time on these data, you can get a lot of intelligence. And not saying this is exactly how it'll be, but it gives indications so we can act more informed. So integrated data fabric, use different type of data sources and do it concurrently in structures and make it available in, look, for example, when you come home and you're bored, look to something like the US AI CyberSeek that gives a complete heat map over US, or where are job openings, where is demand, what type of skills within cybersecurity are opening up, and then linking to different course avenues. So really a way for you as a learner to be able to navigate. I have tried just to make it a little bit more concrete. I tried again. I think I collected about 150 or so job ads from companies around and about in Europe and tried to mine them in terms of what are the type of skills and tasks that come out of these jobs. And as you can see on the left side, there are skills that I then have associated with tasks. And on the other side, I've said, okay, so if these are the tasks and the skills, how can that be translated into micro modules? And how can this combined then point to development for the AI robotic systems engineer? Pretty simple exercise that is scalable. I've been working a little bit with the wind technology people at DTU, Danish Technical University, who right now are starting occupational pathways that way within wind technology around AI, green digital transition. But it's not the way we are working with anticipation in Europe right now. And obviously you can go in here also, I should say that, because you could say, well, this I already know. You can maybe have an assessment so you can demonstrate it, have a badge that you can put on your LinkedIn. And you can flexibly then put together your program in whatever format that fits with you. So we have talked about micro-credentials this morning. Does everyone know what micro-credentials are? Because it has nothing, in fact, to do with content. The core of micro-credential is that there's an assessment up against standards and transparent standards, and that they are portable and shareable. And portable and shareable means that they are tamper-proof, they are in digital format using blockchain. And with blockchain and digital tamper-proof formats, then you also have tons of options to tag them, to use metadata that can be read by automated HR systems to make learners stand out. You can tag them, for example, we heard this wonderful presentation this morning with building prototypes. And I strongly believe that whole idea of sketching and prototyping is not just for small children. It's also a way to think about AI literacy and broader digital literacy than just tools. So the same component can be also put in a micro-credential, because you can demonstrate, if I created an artifact, that can be some open software code. It could be a prototype for sustainable house build of cow manure or whatever it could be, but I could show it on my roof. And it's interesting, some years ago, I did a study for Danish Confederation of Engineers and asked them a lot about their learning expectations, their learning styles, what they wanted out of learning. And they said this history with ECTS points, of course, it gives some indications, but we do have a degree already. So that's not what we are most focused on. No, we want to be able to demonstrate that we can actually do what we have learned. So this competence-based idea of assessment, authentic assessment, I also think goes very much into demand-driven micro-credentials. So if we look now at the European scene, what is it we see? We have a gazillion pilots because all the university alliances are doing something. Some may have maybe now 6 or 7 or 10 micro-credentials. Others might only have 2. Another might have another 10. Some look exactly the same, but each with their own little alliance, with their own little portal. And if we go then to European Institute of Technology, the same phenomenon, another set of portals. And if we go to the skills alliances, whether it's in auto or food or whatever, another set of portals. And I'm thinking about the poor employer of a company who doesn't have HR people and who is a 50, 100-man company who would like to invest in their employees. How on earth are they going to navigate in all of this? And the same also if I, as a learner, want to make use of all these sources. It's impossible. So I think you as organizations also have, in the Nordics, we could think about maybe not so many pilots to build content, but to build infrastructures, common infrastructures for skills anticipation, common infrastructures for provision of training. Because right now, for example, one of the alliances is building some really interesting environment for authentic challenge, dealing with authentic challenge and problem solving and building prototypes and whatnot, developed at Tampere University in Finland. But that should be there for infrastructure for all of the alliances. And it could be built almost like banks. They build solutions, or our Danish infrastructures for banks build solutions with APIs. So the individual universities could build on top of it. So that could be an option. And again, then thinking about it, not just standalone courses. Yes, of course we want standalone courses because it might be that I need just this, but we also need to think about pathways and pathways into these changing occupations. I'll give you now, because I'll give you a view of this. This is sort of my idea of what it could look like if we look ahead. We have the individual learner there. She can go and have their competences validated, have their skills passport. That all goes into the Europass credentialing infrastructure, which is built. Then on top of that, we also have what's developed in the US is credential value index that goes in and assesses the labor market value of all these credentials by looking at labor market mobility, upwards mobility, salary increase, moving over to sunshine sectors from downhill sectors and so forth. Very granular data. They've done this now for 30,000 credentials. We could do the same with the data we have in Europe. And that way we have an equal playing field between private and public providers, because micro-credentials are skills currency. They only are value if they help you move along. So we have the skills intelligence. We could link it into, companies could link it into their HR systems and the talent marketplaces, whatever they work with. And individuals can then put together pathways, and as they go along, put it in the skills passport that can then be read when they apply for a job or when they apply for a project or whatever they do. Can't be so difficult, but it needs collaboration and it needs scale. So we need to move from this pilot thinking, more pilots, thinking about the service business model and systemic. I will end with this because we should also have a little more time, but that should really be my key message around STEM. Thank you.
Thank you.